Assalamualaikum sir, thank you for joining us today. We are excited to present our project on Introduction to Data Communication and Networking. Introduction to Data Communication and Networking. Data communication and networking are crucial for modern businesses. A well-designed network can enhance communication, support more devices, and ensure reliable performance. Our project focuses on designing a scalable and secure network topology. Network topology design. We chose a star topology for its scalability and reliability. Each device connects to a central switch and making it easy to add or remove devices without major reconfiguration. The switch capacity supports multiple devices and our design ensures easy modular growth.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Izwan and now I will be presenting about the justification for our network topology. The first one is scalability. The ability to grow and accommodate more devices without significant changes is crucial for any network design. Our current setup is highly scalable for several reasons. The first one is switch capacity. Switch capacity allows for easy addition of more devices. Each switch supports multiple devices and integrating additional switches into the network requires no major reconfiguration. The second one is router capacity. The router capacity to handle increased bandwidth and devices ensure efficient network scaling. High-performance router with greater throughput can replace the current router if needed. The last one is future-proof design. Using switches with a high number of ports that can be stacked ensure the network is future-proof against moderate to significant growth in device count. The second one is reliability. Ensuring minimal downtime and consistent operation is key to network reliability. The first one is redundancy. Adding redundant links between the router and switches can prevent single point of failure. For instance, connecting each switch to the router with multiple cables provides failover path. The second one is quality hardware. Utilizing high quality, reliable hardware for the router and switches ensuring long-term reliability. Investing in business class equipment with a good warranties and support option enhance network reliability. The last one is load balancing. Distributing devices evenly across the switches help balance the load, preventing any single switches from becoming a bottleneck. This ensures no single point is overload, contributing to overall reliability. The third one is security. Network security is critical to protect sensitive data and ensure authorized access. The first one is firewall and intrusion prevention. The router should have a robust firewall and intrusion prevention system to block unauthorized access and detect potential threat. The second one is network segmentation. Implementing VLAN within the switches can segment the network, isolating sensitive devices and preventing unauthorized access between segments. For instance, separating PCs from laptop and printers enhance security. The last one is access control. Enforcing strict access control policy including FAC address, filtering and role-based access control. Ensure only authorized devices and users can access the network. The last one is cost. Cost consideration including the initial setup, ongoing maintenance and potential future upgrade. The first one is initial setup. Using switches and a single router is cost-effective for the initial setup. Business class switches and routers offer a good balance between cost and performance. Second, maintenance. Ongoing maintenance costs are minimized by selecting reliable hardware with a good support and warranty option. Regular updates and monitoring can prevent costly downtime and repairs. The third one is scalability and future costs. The design scalability ensures future growth can be accommodated without significant overhaul costs. Adding new switches and devices is relatively inexpensive and does not require a complete redesign.
Assalamualaikum and hi everyone. I'm going to present about design and configuration. Without further ado, let's get started. Step 1. Configure the router. Access the router's CLI, which is Command Line Interface, and enter the following commands to set up the interfaces. Enable configure terminal, interface Gigabyte Ethernet 0/0/0, IP address 192.168.1.1, 255.255.255.0. No shutdown exit. Interface Gigabyte Ethernet 0/0/1, IP address 192.168.2.1, 255.255.255.0. No shutdown exit N. Step 2. Configure switch LAN 1. Access the switches CLI and enter the following commands. Enable configure terminal interface VLAN 1, IP address 192.168.1.2.255.255.255.0. No shutdown exit N. Next, I'm going to explain about step 3, which is configure devices in LAN 1. For each device in LAN 1, open the configuration window, go to the desktop tab and select IP configuration. Assign IP addresses within the 192.168.1.0/24 range. Step 4. Configure switch for LAN 2. Access the switches CLI and enter the following commands. Enable configure terminal, interface VLAN 1, IP address 192.168.2.255.255.0. No shutdown N. Step 5. Configure devices in LAN 2. For each device in LAN 2, open the configuration window, go to desktop tab and select IP configuration. Assign IP addresses within the 192.168.2.0/24 range.
My name is Syahrul Izwan bin AHMAD BAZLAN. So, for the next slide, which is testing and result, we will do two testing types, which is screen test and test road. Testing is a critical phase in ensuring that our network operates correctly and efficiently. Let's take a detailed look at our testing process and result that we need to achieve. So, firstly, within the LAN 1, what is our objective? Our objective was to verify connectivity between devices in the same LAN. So, for this testing purpose, we choose laptop 0 with IP address 192.168.1.20. Repeat laptop 1 with IP address 192.168.1.24. So, we use the command ping 192.168.1.24. Then, we expected to receive successful response indicating that packets are being transmitted and received without issues. So, the result is we did receive replies confirming that laptop 0 and laptop 1 can communicate effectively within LAN 1. Next, we need to go to the LAN 2. So, our objective is similarly, we wanted to verify connectivity between devices in LAN 2. So, for our testing purpose, we choose PC 0 with IP address 192.168.2.10. We ping PC 1 with IP address 192.168.2.11. The command used was ping the IP address. Successful responses were expected, indicating that packets are being transmitted and received without issues. So, the result, we received the expected replies, confirming that PC 0 and PC 1 can communicate effectively within LAN 2. Okay, next we go to cross-LAN connectivity. So, what is our objective? Our objective is to test the connectivity between devices in different LAN via the router. Example, from laptop 0 with IP address 192.168.1.20 in LAN 1, we ping PC 0 with IP address 192.168.2.1.2.10 in LAN 2. So, what is the command? We use the command ping the IP address. So, the expected result, we expected successful response indicating that the router is currently routing packets between LANs. So, we receive replies confirming that packets are currently routed through the router between LAN 1 and LAN 2. Next, we go to the threshold test. Our objective is we wanted to understand the paths and hops data packets packed across the network to ensure the connectivity. For example, from laptop 0 with IP address 192.168.1.20 to PC 0 with IP address 192.168.2.10. So, we use the command threshold IP address. The output should show hops first to the router interface on LAN 1, which is 192.168.1.1, and then to the destination device, which is 192.168.2.10. So, the threshold command output showed the expected hops, confirming that the routing configuration was correct, and there was no unexpected delay or misconfiguration. During the implementation of our network, we faced several challenges. Let me walk you through the issues and how we resolve them. So, first issue, VLAN configuration not recognized. So, the problem is the VLAN configuration commands will not recognize or apply as expected on the switch. So, what we will do? First,
we check the switch model to ensure it supports VLAN configuration. Some switches have limited VLAN capabilities. Second, correct commands. We verify that we were using the correct commands, so we need to double check the commands. Here are the commands we use. First, enable, then configure terminal, then interface VLAN 1, then we set the IP address, which is 192.168.112.2, then we set the subnet mask, which is 255.255.255. Then we type the no shutdown and end. Third, we verify VLAN state. We ensure that VLAN 1 was active by using the show VLAN brief command. Lastly, firmware update. Finally, we check that the switch firmware was up to date. Sometimes firmware updates can resolve configuration issues.
In conclusion, the Star Topology network design in this project offers a robust and scalable solution for modern businesses. Emphasizing scalability, reliability, security, and cost efficiency, this design is ideal for creating a resilient network infrastructure. High-quality hardware and modular growth capabilities ensure minimal downtime and consistent operation. Comprehensive security measures protect sensitive data, while cost-effective solutions balance performance with long-term savings. Detailed configuration and thorough testing ensure seamless connectivity and reliability. This project demonstrates a clear understanding of network principles, providing a solid foundation for future growth and technology advancements.